Hi, let's look at chromatography. The first one is TLC, thin layer chromatography. So in this case, we are separating compounds by its polarity using a solvent. And in order to do that, we're going to use a TLC, a thin layer chromatographic plate. So these plates are either um, developed on glass or aluminum, and we will identify using visualization methods and doing some RF calculations, right? So let's look at what is this plate. This plate is mostly glass or sometimes aluminum, and we mark the spots using a pencil. And this is about 10 millimeter height of the plate, and then once it's developed, it should look like this one. So you will have a couple of spots depending on the compound, and we will have a top about 1 centimeter down, 10 millimeter down, a solvent front. If you look at carefully by the side, let's say, and if I can make it 10,000 times uh, bigger, and it should look like this. You have this glass support or aluminum support. It does nothing, it's hold everything. And then you have this silica gel. Its silica gel is actually SiO2. It's basically finely powdered sand, and it's also called the stationary paste. Stationary paste means it's staying everything, they are not moving. Then you're going to add the solvent, the blue one. The solvent is going to crawl up because of the capillary action of the solvent in between these SiO2 particles. And the solvent moves up. As the solvent moves, if we have a spot, let's say black ink, right? So the spot will be on the spotting line where the spots are. So this spot, the blue, I don't have black for this one. So it's, let's say blue spot is the black ink. And let's say black ink is comprised of blue, green, yellow, right? It will be separated. So the red color, the green color, and the yellow color will be separated because they have different polarities, right? So this is separated because of the capillary action. The solvent pull is different, right? Now, let's develop this one. So that's at the end of the development, right? Now, so here is the solvent. You fill about 10 millimeters, and you closed it airtight. It has to be airtight, and you can also add a filter paper behind just to support the moisture. And then once it's developed for the black ink, it should look like that. So there's a blue spot, there's a red spot, there's a yellow spot, and we have a blue reference and the black ink sample. So just to show how does it look like after the development, right? So everything I talked about, this solvent runs to the front because of the capillary action. That is also called, the highest point is called the solvent distance, and we measure that one in millimeters. And these spots are, let's say, labeled A, B, C, and the B is, let's say, 35 millimeters, and solvent front is 60 millimeters. Let's say we measured. It's a good way to measure. And then develop. So, the development, develop means you put the spotted TLC into the solvent jar, right? And the solvent jar is saturated and airtight, and then you will see the capillary action. And if you have colored ones, it will be moving up, right? And the good solvent systems are hexane and ether 421, hexane and methanol 921. So these are pretty good. Um, Non-polar and polar solvent mixtures. And visualization, there are two ways we can use UV visualization, which is you can actually recover the material. It's a very good, nice method to see the aromatic compounds actually. So it will be nicely bluish color. And the UV benches are available in most of the labs, right? The other ones are oxidizing agents. These are iodine, permanganate, and sulfuric spray, and they will oxidize the material, show it in dark colors, and it can be done by people who know, well, chemists, right? And then the standardization. So this is the RF, um, the the retention factor, and that is measured between these two numbers, using the two numbers, right? So let's say we had the 35 millimeter and the 60 millimeter solvent front, and the spot is 35 millimeter. Let's say 36 millimeter, so we can just do the math without a calculator. So that would be 6 over 10, 0.60, because millimeter to millimeter cancelled out. So this is a fraction, and that's always fractions you're going to get, and no units for the RF, right? So the RF is standardized because two people did together, me and my student, and then we will get both very close numbers, even though we have different sizes of TLCs, right? The other one, separated by polarity, silica and water is polar in the silica TLC. And let's say we have one sample of benzoic acid, polar, and let's say ethyl benzene is non-polar, and then they will be separated. So the non-polar will be pushed up because the non-polar compound like A is not holding into the silica, and polar ones like benzoic acid will be holding tight to the silica plate. Okay, thank you.